Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship V3 flight number 12. So let's dive deep into it. So this was integrated flight test number 12. That's going for a bit long. The original plan was 21st May 2026, 4 a.m. Indian time, so to say. However, it was scrubbed, and it was scrubbed so close. I feel bad for people who traveled physically to see that. It's like T minus 40 seconds, and then they scrubbed it. So that was rough, so to say. That was rough. And the primary reason for that scrub was hydraulic pin was failing to do its job. You have to understand, these towers actually have the ability to scrub a launch, meaning because again, it's a critical infrastructure. It does have a PLC logic kind of deal where if it detects like something is not working, yeah, kaput, the end. It will override everything and shut down the rocket. So that did happen. Thankfully, the second window was still there. Second window was on 22nd May, same time. And Elon Musk, after the scrub, I think very recently after the scrub, he is the hydraulic pin holding the tower arm in place did not react. It can be fixed tonight, and there will be another launch attempt tomorrow morning. And it did happen. And this was the first debut flight of V3 rocket and V3 Raptor engine, and hundreds of major changes. So this was a big deal, as in like a fresh start. There was too much overlap and too much mess and too many small changes in previous iterations. This is a fresh start. Like, okay, this is something that's supposed to be serious. That's supposed to work. So this is IFT number 12. Now, tower, that was their absolute weak link, so to say, meaning even if, let's say, their rocket worked, even if they solved all the problems, the launch infrastructure was not there. The tower was getting damaged every launch. Now, that's normal for NASA systems. Why? Because NASA's expect every launch to take like, basically cadence of launch is low enough, gap so far enough, they can easily do it. And why do it that way? Because it's cheaper. If you directly make a flame trench and the infrastructure that can tank multiple launches a day, yeah, that would be idiotically expensive. It would be cheaper to build good enough and service and repair it after every launch, especially if every launch is like 4 months apart, 6 months apart, or a year apart. So this time, because again, SpaceX's whole selling point is cadence, rapid cadence, meaning they're gonna do it regularly or even multiple times a day, which again, that's stretching it, but that's their aim. And fundamentally, their launch tower could not have done that. So they built a second launch tower. This puppy is overbuilt like tank because it's supposed to tank it without refurbishment. That's the critical aspect. It has to tank it like just nothing happened. Let another rocket go, let 5-6 rockets must fly, only then inspection will happen. And hopefully nothing major would have been broken at that point in time. So this was the only part of the infrastructure that worked flawlessly. Like this puppy tanked it without any issue. And so far, I think they are happy with this design, as in like this will be replicated in all other towers and it works. Now, the other bottleneck after the launch tower is they do not have basically air distillation tower, as in air separator unit, as they call it, because they are drinking so much liquid oxygen and so much liquid nitrogen. They can't support the infrastructure with trucks. Again, that will be the bottleneck. Assume you have rocket ready, but yeah sir, we are waiting for trucks to come and deliver liquid oxygen. So, and again, whenever you are paying truck for liquid oxygen, where do you think they are getting it? They are getting it from air. So doing this was no brainer. So why did they took so long? Most likely, most logical guess is they do not have the power supply, as in there was no big enough substation that could have pulled big enough line, because these are power hungry. And whenever you are paying for liquid oxygen, that's what you are paying for. You are paying for the electricity bill of this and transportation. So electricity bill would be still there, but transportation would disappear. And not to mention, now you can fill up your tank farm 24/7. Like you can, even if the output is not very high, you can slowly fill up a reservoir. So that will take care of their liquid oxygen and liquid nitrogen part. And there is a plan, which again, it's not 2 years from now. This will happen very soon, but this is a bit down the line. There is a gas terminal being built, LNG terminal. This is like 30-minute drive away. If you look into Google Map, you will find this. So this port is designed for LNG terminals. So they're gonna directly pull a line from here to that Boca Chica plant, so to say. So direct connect, the bypass trucks, and then you can have the throughput that you are selling to the public. Without that, like fundamentally you cannot launch it, because trucks, there is not enough trucks that can keep circulating the consumables, so to say. For rapid cadence, these two things have to come online, at least this, because again, they consume so much oxygen and so much nitrogen for testing. It is unwise to drink it from someone else, like make it your own. So This is tower system. This I am pretty sure will be done very soon. This will take a while because again it's a governmental contract, but it will happen soon. And the tower, I think they're like, yeah, I think for next few launches they are gonna be happy with this. It's like, this is good, this is fine. Let's put the pen down, work on other things. So this is the launch infrastructure. Now we come to the booster. Booster, new design, new engine, and new topology. So many things new because the biggest topology change is that instead of having 4 grid fins, they have only 3. And again, they are not 120 degree apart. They are 90 degree apart. It's like, wait a minute, that means there is 180 degree where there is no grid fin. Yes. Why? They figured out the way they are sending it for landing. They are not crisscrossing it. They are not landing like this, crisscross. They are landing like this, meaning one is always in the shadow. So the shadow part is like, they can just remove it. So they threw it away, simplified the structure, but the weight savings they spent on making the grid fins bigger and beefier. So these grid fins are now much more oomph. So they should give more authority without having the complexity. That was a big change. Launch happened, things did work, but one engine pooped the bed. Performance was not well, so to say, and it took out something critical. Let that be very clear. It's unknown how big our damage was, but it was damage. It was not graceful shutdown. It was something that achoo. And the best example we got that it was bad is during this, what we call stage separation. When stage separation happened, you could literally see the telemetry data where it's like, okay, engine 1 fired, engine not fired, and you can see that, like, again, not in just GIF you are saying, I'm saying in the video, you could see that, like, hey, it's trying everything, and it gave up. Computer gave up midway. It's like, nope, not happening. So there was a serious damage. And it did try to relight engine again, so at least get the splashdown data. Yeah, it gave up on that also. Only one engine lit at that point in time. So there is a very good chance that engine that sneezed had some serious issue, and it did took out something that was linkage to either some sort of safety or some sort of reignition circuitry. So yeah, booster does need a lot of work. Now, worst case scenario is they have dual issue, as in Raptor 3 engine also has some issue, and because they changed so much in the plumbing is causing some issue. That would be very hard to diagnose, but let's see what they do now. So what was Starship? Well, the Starship, it also had an engine malfunction. That's why it's more likely that Raptor 3 is need a bit more time in the oven. So it did have, and again, it had from start, the moment they turned it on, the engine started, and a few seconds, pooch, it's also sneezed, the end. The engine did not come online afterwards. It did reach targeted suborbital trajectory. Now be mindful, while they can have what we call engine out capability, it does come with a compromise, because there is a very good chance you do not have enough margin. You do not want your engine to go all out simply because you want it to be reusable, but you do not want your engine to be very low throttle, like let's say 60% throttle, because that means you have way too many engines. So there is a balance point. Now, we do not know, you do not know, I do not know what is the sweet spot or what is that they are achieving. So, but let's just say it's 85% throttle capability, as in all engines, if working, they will be at 85% throttle. If one goes out, others will pull up to, like, 90% or 94%. Fine, great, awesome. But it's very unlikely it has that much room. So whenever one engine goes, it will have a penalty, depending on how much throttle margin they had. So worst case scenario is that while they could send payload to orbit, they have to scrub the, let's say something like this happens, and they had the payload, like fully loaded 150-ton payload or 100-ton payload. They still be able to finish the mission, but they will not be able to do re-entry or landing, simply because they will run out of propellant. Compensating with, again, if all engines just go bonkers all out, there is a penalty, like something will have to give if you have that. It's almost like, how airlines, 4-engine airlines can survive one engine out without any issue, like passengers will not even know that one engine was kaput. But if 2 goes, whew. So, but again, the moment it lands, you have to do a full investigation. Here, that's a bit more messy. So this engine out is not a what you call clean sheet, and be mindful, engine out on booster is far more gentle compared to engine out on a Starship. Starship engine out is like, you don't have enough engines. So fundamentally, and they did manage to deploy payload, which they have been doing for some time. So deployment did work, and they had the wisdom is like, hey, we are throwing these things away, this is gonna re-enter, why not put a camera and a flashlight and some radio communication? They did, and this is the first time we are seeing the Starship in orbit, or in orbital level height from outside, and that's cool. And this is the refueling system. Now, I have a feeling, which again I can't validate, but I have a feeling that this design is locked in a chicken and egg scenario, meaning even though NASA is flat out asking them, please de-risk the mission, they can't de-risk the mission, meaning they can't do what China is doing, where it's like launch 2 of them and then dock into lunar orbit and complete the mission and come home. It's much cheaper than having 150-ton to orbit rocket. Okay, why can't they do it? They don't have payload fairings. They can't have payload fairing. The design wise, they can't have it. Not only the structure does not support it because they have heat tiles and wings and all that, they also have fuel tank there that is for re-entry. So it may be because they said like they're gonna refuel and launch it again, they cannot have a deployment window, meaning this whole thing has to be utilized because they can't come up with a door design. So that's a very messy thing. Again, great for Starlink, but Starlink is a low Earth orbit target. Anything heavier than that, how the heck you're going to open the door and deploy the payload? That door design, there's not even a theoretical concept. How the heck you're going to deploy something? And again, let's just say, if it's not dense, let's say satellites are very dense, but habitats, they are heavy, but they are hollow. They are huge volume-wise. How the heck you're going to deploy it? So that is an issue, which again, that's why I'm pretty sure they are so stuck with refueling. They have to do refueling. Otherwise, they can't do anything other than Starlink. So fundamentally speaking, they did deploy the payload. It did work. We got the footage from the first outside ever. That's great. It did survive re-entry. That's good. We just do not know how well. Meaning, because there were still sparkles, that generally means some tiles were degrading. Again, minor degradation, who cares? Major degradation, people care. And again, you have to understand, you are targeting rapid reusability. So even minor degradation is just like, and again, it's not supposed to degrade, spall how Orion capsule does, because again, it's supposed to spall and fall off. So Orion's having sparkles during re-entry, that's expected. Starship having sparkles during re-entry is like, again, it could be minor inconvenience to, major inconvenience, unknown. And splashdown was a bit dramatic, I have to say. It's just like, I do have to say, what did explode here? Like, did they had that much propellant left, or it was the demolition charge? Like, it was very dramatic. It's like, boom. So, and again, that's the part I'm not getting. It's like, why don't just let it be? Because again, you have a drone there. You can fly the drone close by and inspect everything. That will give me far more data compared to anything else. So, I'm not sure. So, Starship was like, again, this is pointing to Raptor 3. It does need more time to cook. So what can we expect in the future? Here's the deal. There is a very high risk of delay, as in integrated flight test number 13 may not be orbital. Not a guaranteed, may not be orbital, because they do need one truly flawless, and as in ideally booster catch and ideally Starship catch. Because if Starship gets stranded in orbit, that's a big mess, like a big mess. So that's a serious thing that they have to figure out how to deal with. So fundamentally, they do need one system where it's like nothing bad happened, like nothing. It's supposed to land, it did land exactly how it's supposed to. It's supposed to go into orbit, no engine failure, especially in Starship. A booster might be able to tank some engine failure. Starship does not have that much of wiggle room, especially if it's in loaded condition. So they really have to need one flawless mission. They might be able to push it. I doubt it, because again, Starship stuck in orbit or having an uncontrolled re-entry will cause airlines issue. And it has happened. So yeah. And Artemis Trust is a very clever thing from Jared Eisman, because here's the deal. Why the heck this got money from Artemis? Well, here's the deal. This was missing deadlines, as in it's supposed to be done by now, but it's way far out. And again, you haven't even had like 12, 13 testing is never done in rockets, never. The furthest a rocket goes generally is number 4. If you cannot get it done by 4, the end. Be it Soviet Union moon rocket or Falcon 1. That was boomed 3 times. 4th time it was the charm. Then they cancelled the project. Falcon 9. That also did not went boom this many times. So as in deploy things into orbit. So compare that to Blue Origin. They launched 3 times. 1 time pooped the bed and 2 times reached the orbit. So that's a normal. Even SLS deployed things into orbit. So this rapid cadence is, that argument is starting to falter. Like number 12, number 13 is like, and NASA knows this. They knows that, like, they cannot beat China with this sort of approach. It sounds cool and fun to say. It's like, oh, we're gonna have refueling. It's like even 10 refueling will bankrupt the whole system. Like, you require 10 launches, very quick succession. You don't have 10 launch towers, so you can't just have that means you have to require refueling and all that. So refueling, and I mean booster refueling and all that. So 10 So how many boosters you gonna make? Like 3 booster, 4 booster, 4 fully functional booster, all of that. Like, do you have the land catching infrastructure for all of them? So all of that, like once you actually do the logistics calculation, it's like you're pushing it too much, and you might not well have that much LNG available. So China knows that, and China knows the fact that they're gonna do what we call lunar flyby Artemis 2 by the time 2027 end or 2028 early. So that's gonna happen. That's sorted. And it's like, okay, but that only brings them to NASA level. Here's the deal. China knows what to do after. That's the biggest difference. China is building everything in a systematic way. NASA had no idea. And again, it's not NASA's fault, it's a administration's fault. Every administration was like, what if we did this? What if we smoked weed like Obama? And he's like, what if we did asteroid redirect mission? That was the single dumbest thing I have ever heard. But again, they did destroy time. This should have been sorted for them. Sorted, like, bro, we got this. SLS can easily do lunar mission. It's like, no, we can't do it. We don't have a lander. So lander contract went out. This is behind schedule. This became out of a necessity. So 2027 is a competition. Jeff Bezos, Elon Musk, go. Deliver the damn thing, and whoever delivers it will have exponential monetary advantage, because they're not going to risk an untested system for astronaut delivery to the moon. That's not happening. If Artemis 4 is supposed to land people on moon, it has to be done on a system that was tested in Artemis 3. Artemis 3 Starship is way far behind for Artemis 3 to be done in 2027, let alone even in 2028 it would be pushing it. So unless they have like rapid cadence, where it's like, every month they are launching, or 2 launches per month, and sort out all the problems, only then they can achieve it. So fundamentally the best way is like, don't spend more money, compete both of them, because again, you can talk the talk, you can talk Starlink and all that, but if you became the guy who is like, okay, who made the rocket that allowed astronauts to walk on moon before China, and the answer is Blue Origin, the end. So that's going to be interesting. And be mindful, moon lander Mark 1 testing is already going on in NASA, as in like NASA has this hardware. They are seeing it, how it works and all that, and is supposed to launch on 4th one. The 3rd one supposed to be the target point, but 3rd one pooped the bed with 2nd stage sneezing. So again, it did not explode. It did sneeze, but they are like, okay, it sneezed, performance is not good enough. Let's sink it into low Earth orbit, as in like to re-entry, unplanned re-entry. That's going to happen. If they land it properly on moon, the likelihood of them actually delivering the full scale one that they can do in low Earth orbit and testing is high. So let's see what happens. Basically, NASA can't spend more money. So the only way is ego competition. Fire 2 missiles at each other, which is Jeff Bezos and Elon Musk. And in the time frame, it must be done before what we call China. And you're like, okay, why that part matters so much? Here's the deal. American public is not as interested in science as they used to be, and there is a lot of anger in public is broke. And in that sort of scenario, if you're saying, hey, we spent billions of dollars and we still got our ass handed to us via China, yeah, shut down NASA. Now again, I do not expect pure shutdown, but I do expect severe budget cut if they fail. It's unlikely they're gonna go like, Soviet Union kind of like, oh, we're gonna spend more money and we're gonna go YOLO. Yeah, that's not the current climate. And again, that's why Jared was there. It's like, let's see what you have. And that's why he's asking, like, please de-risk the mission. But again, de-risking the mission requires payload fairings, like open the door, deploy the payload. That will solve all the problem. But who the heck designed the door in like 1 year or 2 years? So this whole thing is basically the penalty of that. You cannot have what we call payload door. They might have to build a sacrificial Starship to do that. Although that will give you more tonnage. That may be a good thing. If they're like, hey, just sacrifice few engines to the sea gods and just like have fairing. Just bite the bullet. So let's see what happens, because again, it has to be done before China, and there are 2 billionaires fighting, and one of them have far more what we call concrete plan on what to do, and their rocket is 3-2. This rocket is 12-0. So let's see, future is going to be interesting. Next 2 years, we're going to have a lot of ego fights. It's going to be fun. So this was my presentation on basically what happened with integrated flight test number 12. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my excitement. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.